Okay. So students will start with our class. Okay. So last class we had discussed a few concepts. Like we discussed the Heisenberg's uncertainty principle. Then we also went to de Broglie's equation. Okay. And there are some problems to be solved based on the energy of the hydrogen atom. But what we do is we'll do it the problems at the end. Okay, all together. So I will start with some theoretical concept today. I'll start with quantum numbers. Okay. Very, very important, okay? From your exam point of view also. Like minimum I can say 2 marks question will be asked from this. Okay. So the first one, the first quantum number is principal quantum number. Do you all have any idea what the principal quantum number is? You already studied about the shells, right? The M, N, the K, M, N, so on. So basically, principal number is nothing but the number, okay, which is denoted to your shells. So the first point is it is a positive integer with value of n is equal to 1, 2, 3, 4. Okay. So basically, when we speak about the principal quantum number, it starts with, it is basically nothing but n, okay, small n. Principal quantum number means when we speak about the principal quantum number, it can be 1, 2, 3, 4, so on. Okay. Second point, you all have to know what basically this principal quantum number tells us, or what information do we get from the principal quantum number. It tells us the size. Okay. It speaks about the size, and it also speaks about the energy of the orbital. Okay, if you all go through your notes, right, you all will see one formula. Okay, that is En is equal to minus 13.6 into Z square upon N square EV. Okay, so this is nothing but you all have to know as the value of N increases, right, the energy will also increase. Okay, so now if you all see, do you all get any question in your head? Like, because it is not directly proportional, right? So did anyone get the question? Okay, like why, since it is like, it is not directly proportional. But why did I say that, as we increase the n, the number n, so on, like 1, 2, 3, 4, the energy will increase. Why so? Can anyone tell me? Yes, because of the negative sign. Okay. So suppose if we take any larger number here, okay, this particular answer, okay, will be less negative. Okay. For example, if I take n is equal to 2, okay, in one case I take n is equal to 4. So you all tell me in which case my E value will be maximum. Like suppose, like which case if I substitute, if n is equal to 2 or n is equal to 4, in which case? Hmm? Higher energy, I said. I'm not talking about the magnitude. I'm speaking with respect to this negative sign also. So what do you think? It will be 2 or will it be 4? 4, right? How? Suppose if we substitute 4 here, if say my n was equal to 4, again, I don't know, it starts this time only. Normally, like at home and all, I don't get this issue, but when I start the Zoom meet, this thing comes. Okay. So what I was saying is when I substitute n is equal to 4, right? When I substitute n is equal to 4, this whatever value I will get will be less negative value. Okay, understanding why? Okay, same way, if I substitute n is equal to 2, I will get this as more negative. Okay, so if we see the scale, okay, like the normal scale which you have, right? Here positive, here negative. So suppose if we go by that, okay, your more negative will be somewhere here, right? And less negative will be somewhere here. So with respect to all this, what will be higher when n is equal to 4 or n is equal to 2? N is equal to 4, right? Because when we have n is equal to 4, you will get a less negative value. But if we consider n is equal to 2, you will get a larger negative value. Okay, suppose if we compare both the values, suppose if we have a small negative value and if we have a larger negative value, which will be more like, like more in terms of, yes, if I speak about energy, which will be more? The one which is less, right? The negative value which is less. Okay, all I have understood this concept. So since even though I can say my E is inversely proportional to the factor n, the principal quantum number, since even though this is the situation, I can still say if I increase the value of n, my energy will be increasing. Okay? And another thing you all have to know is when we have K, L, M, N, okay, the corresponding like shells will be 1, 2, 3, 4. So these are nothing but your principal quantum numbers. Okay, clear? Okay, if you all have understood the principal quantum number, let us move to azimuthal quantum number. Okay, sorry, azimuthal quantum number is nothing but it speaks about the subshell. Okay, so principal quantum number it focused about the shells. Okay, which are placed outside the nucleus. So we have the K, L, M, and so on. And basically for those shells, we have the numbers 1, 2, 3, 4 so far. Okay, so the principal quantum number it focuses on the shells. Okay, whereas the azimuthal quantum number it will focus on the subshell. Okay, so when I speak about the subshell, like what information like do I get? Subshells are nothing, but you all must have heard about S, P, D, F, right? You all have heard about this orbital? Never heard? Okay, some have heard, some have not heard. Okay, so these are nothing but these are your subshells. Okay, like for example, if I speak about the atom, right? I will have my nucleus and surrounding it will be my shells, like the K, L, M, so on. Okay. Suppose if I speak about with respect to the atom, the shells will be nothing but they will speak about my principal quantum number. Okay. These shells, they will tell me the principal quantum number. So in this case, this will be one, this in this case, it will be two. If I speak about the subshells will be, like in this particular, it will speak about this particular shell, but within this particular shell, it will speak about the inner subshells, okay, which are there. Like this orbital, this shell can have S, P, D, F, okay, so on. This, like how to name it and all this, we will see a bit further on. But for now, you'll have to know shell is a something which is big, okay, which is present outside the nucleus, and into the shell there are something called as subshells, okay, which are S, P, D, F, okay. So when we speak about azimuthal quantum number, it speaks about, or in other words, it gives information about the subshells, okay. In other words, subshells are nothing but your SPDF. Okay. And we also see that if the value of n is same, okay, if I keep my principal quantum number same, like for example, if I speak about 1, 2, 3, 4, right? In this case only, I will have further on subshells. Like for principal quantum number 1, I will have something called as 1s. Okay. Suppose if I speak about my principal quantum number 2, I will have 2s, 2p. Okay. If I speak about 3, principal quantum number 3, I will have something called as 3s, 3p, 3d. Okay. Now you all will have a question like why didn't I write p, d, f here? Okay. There are some rules which are to be followed, which you all won't, like understand it now. You all will understand when we go through those some basic rules, okay? But for now, you all have to know what basically is principal quantum number. Okay, principal quantum number speaks about the shell, whereas the azimuthal quantum number it speaks about the subshell. So when I speak about subshells, you'll have to know that the subshells are nothing but s, p, d, f orbitals. Okay, then there's one statement key. If the value of n, if it is same, right, the energy of the electrons it will follow the order S, P, D, F, but F will have higher energy, then will be D, then will be S. Okay. So first we spoke about these subshells, right, which are S, P, D, F. Second point, what it says, if my principal quantum number is same. Okay. In other words, if I consider like the principal quantum number 3. Okay. Under principal quantum number 3, I will have my 3s, 3p, 3D, 3F. Okay. So now if my principal quantum number is kept constant, okay, then the energy order will be F will be greater than your D, then your P. Understood this much? Do you all have any doubts? Understood? Okay. So this was the first rule, okay? Second one says that if my principal quantum number, is different, okay, if my principal quantum number is different, but if my value of L is nothing but my azimuthal quantum number, okay, like how we denoted our quantum number by a small n, right? We will denote my azimuthal quantum number with a letter small l, okay? So here the second, if you all can read on page number 16, right? It says that if the value of L is same, but the n value is different, then it will follow. In other words, it will be like 1s, 2s, 3s, 4s, 5s. Okay. Suppose if my subshell, that is S, is kept same, but my principal quantum number is different. So then it will follow this order, okay? Like it will give a priority or the energy will be highest for the highest principal quantum number. Understanding? First one, we have seen that if I keep my principal quantum number same and the value of L is different, then we have seen that F will have higher, then D, then P, then S. Okay. Second case, we have seen that if my value of L is same, but my principal quantum number is different, then it will follow the order of the highest principal quantum number will have a higher energy compared to the 4s, then the 3s, then the 2s, then the 1s. Okay. And there is another formula. Okay. Suppose if you all want to find the number of electrons which are present in this particular subshells, right? If you want to find how many electrons are present in S, how many in P, same way D, F, then you have to, there's a formula to calculate it, that is 2L plus 1. Okay. In this case, like how for our principal quantum numbers, they were like, for our shells like K, L, M, N, there were numbers like 1, 2, 3, 4, right? Same way, when I speak about my subshells, right? That is S, P, D, F, we have numbers. Like for S, it is 0, then 1, 2, 3. Okay, but only difference is for my principal quantum number, it starts from 1. Here it will start from 0. Okay, the only difference is this. So when I speak about this particular formula, okay, in this, by this, using this formula, you can find the number of electrons which are present in these subshells. Okay, how will we use this formula? We just have to substitute the value of L. L is nothing but these values 0, 1, 2, 3. Okay. Okay, so now if I ask you all a question that I want to find how many electrons are present in the s orbital. Use this formula and tell me how many electrons are present. 2, right? If I substitute 0 here, it will be 2 into 1, that is 2. Same way for P, 6. Understanding? All have understood how we got 6. Okay. So suppose if I ask you all how many electrons will be present in my 4d orbital, how will you all calculate? Yeah, someone said it. 10, right? 10. You just have to ignore like meaning this principal quantum number. I just want to find how many electrons are present in my subshell. Okay, so you all have to focus only on this d orbital. So it will be 10. Okay. In F, it will be 14. So on. Okay. So clear with principal quantum number and azimuthal quantum number. Any doubts? This side clear? Okay. So if you all are clear with that, let us move on to the magnetic quantum number. You all don't have to by heart that equation for E, okay? This is just for your information. They had given a statement. Basically, you have to just know the statement here. As we increase the value of N, the energy increases. Okay? So because of this, I took this formula. I just wrote it so that you all can understand it better. Z is atomic number. Okay? So don't go to by heart this formula of E. Don't go to by heart it, okay? Just you have to remember the statement, okay, which is given here. Okay. So the third one is magnetic quantum number. Okay. So what does magnetic quantum number focuses or what information does the magnetic quantum number provide? It gives information about the orbital and the orientation of the orbital. Okay. Basically, we have seen the shell, then subshell. Now we will deal with the magnetic quantum number. This gives information about the orientation, as in how it is placed. Okay, it gives the information about the orbital and the orientation of the orbital. Okay, I don't know, you're laughing last bench. Okay, so basically, the value of the quantum number, that is magnetic quantum number, it will be from minus L to plus L. Okay. For example, if I speak about the s orbital, okay, s orbital, as you all said, okay, first we know that it can have various quantum numbers, right? Like, sorry, to be more specific, it can have various principal quantum numbers like 1, 2, 3, 4, so on. Okay. Now speaking about the azimuthal quantum number, there you all have seen that your S subshell can have how many electrons? 2 electrons. Okay. So if I speak about these 2 electrons, it will be placed in this order. Okay. Like this subshell can accommodate 2 electrons. Okay. So this it will be 1, the other one will be 2, the second one. This is the first one, this is the second one. Okay, you place it in that order. So this basically will come when you speak about the fourth quantum number. Okay, spin quantum number. Okay, but for now you'll have to know that this particular subshell will accommodate 2 electrons. Okay, so when I speak about the magnetic quantum number, okay, it can have values from minus L to plus L. So what was our S? When I spoke about S, right? what was the value of L? Zero, right? So suppose if I speak with terms of in terms of this, okay, and I have said that my magnetic quantum number, you represent it with a small m, okay. So suppose if I speak about my magnetic quantum number, okay, I said that it can have a value of minus L to plus L, okay. So if you can, represent this particular value, okay, S is equal to 0 in terms of M. So how it will be? What will be the value of M? You are getting what I said? I said that you represent magnetic quantum number with a small m. Okay. So I said that my small m can have values from minus L to plus L. Okay. So if I know my value of L, okay, the value of L for S is, okay, I'll write it like this. For S subshell, right? My value of L is 0. So suppose if I know like my L is 0 here. Same thing I want to represent and find the value of M. What the answer will be? 0, right? Because 0 can't have negative and positive. Okay. So my M value will be 0. Okay. So if I speak about my p orbital, okay, we have seen about S, we'll see p, okay. I said that the value of p can be, suppose if you all are writing, making a note, you all made a note, okay, other like, because here it is just like I have given explanation like to you all. So if you all want, you all can write it separately in your notebook so that it becomes a practice for you all also, right? Okay. So basically what you all do, for write like for principal quantum number, just write principal quantum number, and in bracket you can write small n. Okay. Then you all can write, so you all can write this. Okay. So these are nothing but your shells. So when you have the K, L, M, N shell, right? The value of n will be 1, 2, 3, 4. This is nothing but your principal quantum number. Sorry. And basic things like, like what information does this give, then you all can, the theory part is already there, right? But like, what is more important, I will tell you all to write on your books, okay? So that you all can understand it like better. So this was about the principal quantum number, okay? Second will be the azimuthal quantum number. You all want me to write, you all can refer to your notes and write me the spelling. Okay. Yeah, so second, right, azimuthal quantum number. We represent that by small l. Okay. So under that, you all can write this, okay? When we speak about the subshells, it will be S, P, D, F, okay? And the value of L, that is the azimuthal quantum number, will be 0, 1, 2, 3, respectively. Okay? Copy this. Once you are done with this, right, you can write this formula. Okay, and you can write, just write to find the number of electrons present in the subshell. Okay, basically this formula is used to find the number of electrons which are present in the subshell. Done? Okay, so now we were speaking about the magnetic quantum number. Same way, you all have to write this topic. Magnetic quantum number we represented by small m. Okay, so when we speak about like the magnetic quantum number, it can have values from minus L to plus L. Okay, so write this. M can be minus L to plus L. Okay. So when we speak about the subshell S, okay, if we calculate M, then we get M is equal to 0. Okay, same way I want you all to do it for P. Hmm. So basically P will, the value of P will be what? 1, right? So if I go by this, what it will be? It can be minus 1, 0, plus 1. Understanding? Okay. Same way, if I do it for D, what will be the values? 2. Minus 2, minus 1, 0, 1, 2. So here it will have 5 values. Here it will have 3 values. For S it will be 1. Okay. And the formula which is there, right, that is an additional formula, that is M is equal to 12 plus 1. This is nothing but to find how many values you will get, okay, for N. When you substitute N is equal to 0, you will get M is equal to 1, right? So this information, or in other words, this formula tells you that for S, for the quantum number or the azimuthal quantum number S, we can have only one magnetic quantum number. Okay? Same way, if you do it for P, what will be the answer there? 3, right? So what information do you get? P can have 3 magnetic quantum numbers. Okay? So basically for D, it will be 5. Understood? Okay. So if I go a bit further on, okay, then it means that suppose if I have speaking about the S, okay, I speak about the S orbital. In other words, okay, in your S orbital, this is nothing but your S orbital, okay? In your S orbital, if I have my S orbital, what will be the value of M? 0, right? It can have just one value, that is 0, okay? Which means, like if I compare your S with your P, okay? What information did we get from this, from the magnetic quantum number? I said magnetic quantum number is nothing but it tells the orientation, okay? Like how are the electrons arranged in that particular atom. First, we have seen the principal quantum number that will tell you the shell, then azimuthal quantum number that will tell you the subshell, okay? In the shell only, but inside the shell, there are other subshells. So it will give information about the subshell, okay? When we speak about the magnetic quantum number, this will tell you the orientation, like how the electrons are arranged. Okay. So suppose if I speak about the P, through this formula, we have found that the value of P will be 3. And which are the values? -1, 0, +1. So in other words, it gives us information that there are 3 magnetic quantum numbers, okay, which is -1, which are -1, 0, and +1. Okay. So suppose if I speak about the D, it will be how many? Here we got 1. Here we got 3. Now D will be how many? 5. Okay. In other words, it will be -1, sorry, -2, -1, 0, +1, +2. Okay. What are the What are orbitals? Orbitals are nothing but your SPDF, the subshells. Okay, I will speak, baby. If time permits, then we can do it now. We just, I don't know, have probably more 20 minutes, right? So in your orbitals, right, we are going to learn the different shapes. Like you have the S orbital. Okay, S orbital. Just you asked me this question, so I'll explain you. Okay, S is just a circular, a spherical, a sphere basically. Okay, the shape of the s orbital is a sphere. Then when we speak about the p orbital, it is nothing but a dumbbell shape. Okay, so on. So since you spoke about orbitals, right? These are called orbitals. Your s, p, d, f, the subshells, they are called orbitals. And when you speak about orbits, they are nothing but the path. Like it speaks about the principal quantum number, like the k, l, m. Okay. Yeah, so we were here, right? So you all understood the magnetic quantum number. Hmm? So same way, suppose if I have my S, okay? S, you when we speak about the different, like subshells of S we only call S, okay? S has no other, it is not divided further on. But when we speak about p orbital, right? It is further divided into px, py, pz. Heard about this? We have, like, suppose if you go more deeper into that, right? This is nothing but you have your coordinates, right? X, Y, Z. This information is about those coordinates, like, where it lies. Your P will be along the X, like PX will be along the X direction, X axis. Then your Y will be along the Y. Z will be along the Z. Okay. So in that way, this whatever 3 values, right, we have got for our magnetic quantum number, they are nothing but our PX, PY, PZ. Okay. When we speak about the D, right? D can have DXY, DXZ, DYZ, DX square minus Y square, and the last one is DZ square. Okay, so probably in our further classes, like we are going to draw the shapes of all these orbitals. But for now, you also have to remember that since we are speaking about the orientation, right? In S, we have seen the magnetic quantum number will be just one, that is 0. In our P, in the case of P, it can be 3. Okay, Px, Py, Pz. When we speak about the D, it can have 5 mag magnetic quantum numbers, okay, which are dxy, dxz, dyz, dx square minus y square, dz square. You all will also know, like, why it has got those names, because since I have spoken, like magnetic quantum number speaks about the orientation, the axis tells us like where do they lie. Okay. In maths, I think maths you all have learned about the X, Y, Z, right? So they fall somewhere in those orientation axis, X axis, Y axis, Z axis. So basically these orbitals, they fall in those axes. So because they fall in those axes, they have got this X, Y, Z, so etc. Okay. Understood about the magnetic quantum number? Clear? This side clear? Sure? Okay. So last one is our spin quantum number. Okay. So spin quantum number, it basically tells us or it gives the information about the spin of an electron. Okay. Now, in the case of our s orbital, okay, we just found one magnetic quantum number, right? So we just drew one square, okay. In the case of, p orbital, we had found three. So hence 1, 2, 3, okay, which we named this as px, py, pz, okay. Now in the case of our d, it will be 5, right? So it will be dxy, dyz, dxz, dx square minus y square, dz square. Okay. So when I speak about all this, and we also have seen like the value of the magnetic, the m, small m will be 0 for this. In this case, it will be -1, 0, +1. In this case, -2, -1, 0, +1, +2. Okay, this I've seen. So from this will comprise of all three quantum numbers. Okay, first principal quantum number, second azimuthal quantum number, third one will be magnetic quantum number. So this information we have reached so far. Okay, we have done three quantum numbers. We have reached so far. The last will be the spin quantum number. It basically tells the spin of that particular electrons. Now you will also have to remember that this particular subshell, okay, will accommodate two electrons each. Suppose if I speak about the S, it will have two electrons. This is nothing but your spin, okay? This is the top spin, this is the down one, okay? We also can say that this one can be clockwise, the other can be anti-clockwise, okay? But you'll have to write it in this order. You can't have two clockwise. This is wrong. This also rules are there, which you all will come further on. But you'll just have to remember that this particular subshell can accommodate two electrons, okay, which we represent it in this. One will be on top, one will be downwards. Okay. Suppose if I speak about my P, how many electrons will be accommodated in P? 6. So how will we do? 1, 2, 3, 4, 5, 6. Okay. There is another rule which tells, you just can't move like this. This is wrong. It should be like this, follow one order and then come back. Huh? What? Is it like the? I know it is the same. It is the same, but there is a rule, like how you all will come to know whether like there is, like further on, if the p orbital has only 5 electrons in it, how will you place the 5 electrons? Suppose if you say your concept, right? How did you say like this, right? It is still right. Okay, you will get your marks. Okay, because you said, okay, like according to the rule, what did I say? You have to go in one order and then come back, fill the next line. Okay, like it is like this. I said something like this, right? But according to you, you said that we can, like we just asked whether we can go like this also. It means the same you said, In the case of P5, it will be the same. But when I speak about my P4, if I follow the order, something like this, okay, 1, 2, 3, 4, and you follow the order 1, 2, 3, 4, is it the same? No, in this case, it will be wrong. Okay, for some cases, like for some of the subshells, it is right. Like for P5, it was like my case also was the same. What you said also was the same. We got the same answer, right? But for some, like other than 5, like if I consider P4 and all, you don't get the same thing. Okay. So this also is important, but these rules and all, like you all will come across further on, okay? But just like I thought of, like giving you all some information about like how to use, then it becomes easier when we deal with those concepts, okay? So now if I speak about the D, how will I do? I will do the same order, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Another thing or most important thing is one particular subshell, like your px, cannot have the two electrons of the same spin. It is wrong. It can't have. It doesn't exist in other words. In other words, I meant that same spin as in, this is called same spin, right? So in one of your subshell, that is in px, you can't have two electrons of the same spin. One should be clockwise, the other one should be anti-clockwise. One is top, the other one should be down. Both can't be top. If both are top, then it is wrong. That particular atom will not exist only. Okay, so basically the spin quantum number, it focuses basically on the spin of the electrons, in which no two electrons can have the same spin, as in this. Okay, a bit further on I'll go. When we speak about the top spin, right? The one which faces on top, like points on top, that is plus half. Okay, when we speak about this, right, downwards, it is minus half. Okay, all have got this, all understood, all four quantum numbers you all have understood. Any doubts? No doubts? Okay, what's the exact time? I'll probably start the test 35. What's the time? 5:30, exact 5:30. My watch is a bit like further on because of that. So what I'll do, I'll give you all the test. I was planning of giving you all at 5:40, like half an hour. Okay, we will do a small concept about the shapes of the atomic orbitals. Shapes, yeah, of the atomic orbitals. Like we spoke about the orbitals, right? SPDF. The shapes of this also, this question, right, about the spin quantum numbers. No, not about the spin in general, about quantum numbers, that is all four. Yeah, very, very important. Okay. 100, you can say you can go beyond 100 also. 110% it comes for the exam. Like 1 or 2 mark is asked here. Very, very important. Okay. So they can either ask you all like, like how many electrons can be present in your 4s? How many? Two. Same thing which we had done. Okay. So such questions you all can expect. Or they can give you all any, like they can give you all any quantum number, like say 4p. Okay. And they can tell you all describe, or in other words, explain the all four quantum numbers. So you all can say the principal quantum number in this case will be 4. Then the azimuthal quantum number in this case will be 1. Okay, when we speak about the value of m can have values from -1, 0, +1. Okay, what? What 3? M can have values of 3. What I said? I said something. -1, 0, +1. So these are the values, okay? And if I speak about the principal spin quantum number, the spin quantum number either can be plus half or minus half. This type questions, like very simple ones, okay? I think I want, okay, I'll do some part because the thing is, I don't want to miss upon lectures also because I think he's starting the earliest, right, by 20th. So because of that, it is like last, at least on 15, 16, 17, one chapter, one class, I wanted to revise, like what possible questions and all are asked. So I wanted to keep 3 days for that. And the next chapter also, of periodic properties and all that also is very important. Like now, whatever concepts are left, right? Those are important. Why I'm saying important is with respect to further on, like this, whatever board theories and or whatever you learn, right? That is not, maybe it is important for your exam point of view, but if you consider like, some other chemistry chapters, like, like be it your 11th further on or 12, these theories and all are not that much important. Just for it is there, like theories are there for your exam. Let me repeat myself again, okay? Don't. don't take it as, like don't study and say that I said it is not important. For your exam point of view, for your 11th, the chapter is included. But if I just consider this chapter with, like with a long perspective, okay, be it your 12th standard and all, then these theories are not used further on, I'm saying. Okay, so just for now, it is like used, like those, all the Bohr's model and all which you have, right? Because they are two basics, right? So it is not used. But this principal quantum number, then those periodic properties about electron enthalpy and all, very, very important. Even for bachelor's, even for master's, it is very important. So because of that, I wanted to give more time to those concepts. Like, and here and there, suppose if I fall short of time, then Sundays I may conduct, okay? Like it will be fine, right? Okay. Just tell me when it is 5:40. Okay, just let me know when it is 5:40. So for what time it is? 35. Okay. So next topic I want you to write. Okay. Okay. Shapes of atomic orbitals. So if I speak about the shape that is of 1s, it will have the shape of a sphere. Okay, round. Okay. If I speak about the 2s, it also will be a sphere, but slightly bigger in size compared to your 1s. So draw this one a bit bigger compared to the 1s. Okay. So on. Suppose if we have 3s, it will be more bigger. Sorry. Okay. Then we will speak about the p. This was about the s orbital. You all can write here s orbitals on your books. Under s orbitals, write this. Okay. Draw this. One thing you all have to note here, 1s, the sizes. Okay. If if in your question paper it is asked, okay, like the shape of 1s and 2s. What you all have to keep note, keep 2s is slightly bigger than your 1s. Okay, this you all have to note. So just draw the sizes in increasing order. Like since I had said, like the energy value will be greatest for the highest principal quantum number, right? Same. So 3s will be bigger than your 2s than your 1s. Okay. Now speaking about the p orbitals. So if I speak about the p orbitals, okay, so now I have my px. Okay, I had said start that p orbital, the shape is a dumbbell shape. So suppose if I say px, where it will be along the x, right? So what I will draw, this is my x. So I will draw something like this along the x. Draw. This also is very important. This comes for 1 mark and all. Like most of the higher secondaries, like have asked in the papers. You are not drawing. Fast, I have to conduct the test also there. Done. Now, if I speak about the py, where it will be. So yeah, so you all can draw along the y. Okay, sorry, this is py. If it is py, it will be along the y direction. And if I speak about the Z, where it will be along the Z. Simple. Done? Okay, so all done. We will stop, right? We will stop with our class. Now we will conduct the test. I hope you all are prepared.